Hey guys, Mr. Gran. If you were gone yesterday in class yesterday, here's a little supplemental video to get you caught up on what we did. It's pretty quick, not the toughest thing that we're going to do this semester, so hopefully this works out well. So the natural base, E. E is just a mathematical constant. It's a special number. Pi is another special mathematical constant. It's 3.14. E is about 2.72. And in pre-calculus, we'll learn a little more about why it's such a special number. But for right now, we want to just get used to playing around with it and understand that it is a thing. So the first thing that we're going to be doing is graphing. So graphing something like this, e to the x plus 2. If you look at your graphing calculator, down near the number 4, there's this button that says ln. And right above it, there's a little blue e to the x. So that's what we're going to be using to get the number, or the letter e in there, is second and then ln. Don't use the capital E that's in here. That's not going to work out. So if you plug it in, it should look like this, right? E to the x, hit the arrow to get it down to the regular script, plus 2, and you're good to go. What it's going to look like is this. Now, this just looks like any old exponential function, and that's because it is. One thing that's special about exponential functions is they have a horizontal asymptote. So if you look at the table and you start scrolling into the negatives, what you're going to notice is that this gets closer and closer to 2, but it never quite gets there. Your calculator will eventually just round to 2 because it gets so close that it can't not express it as 2 without using more than 5 digits or whatever the table's maximum number of digits are. So when we graph it, one thing is going to be to graph it relatively accurately. The second thing is going to be to identify where that horizontal asymptote is. And both of them are pretty simple. If we go to the table, I'm going to choose 5 total values to plot that are around the center of the graph. In this case, the center is 0. If we start shifting it horizontally, that center will move. But for right now, we'll just use this one. Oops. Come on. There we go. All right, so that table of values looked like this. The x values I was going to choose are -2, -1, 0, 1, and 2. So 0 is the center of my graph, and these are 2 values to either side, so I got 5 total. I'm going to round it to the 10th just because I can't draw a graph more accurate than the 10th, and I'm not really counting the table as part of the work. It's just sort of my organization system. Okay. We've got our horizontal asymptote graphed as a horizontal dashed line, and then we're just going to plot the 5 points. .4 won't quite fit without drawing on the board, so I'm going to leave that one off there. You guys plot all 5 points. And that's all it is for graphing it. Second part, identifying the horizontal asymptote as an equation. The equation of a horizontal line is y equals a number. And the nice thing about these is it's just whatever the number is here, whatever that constant is, your vertical transformation. We talked about earlier in chapter 7 that exponential functions have a horizontal asymptote at y equals 0, but then if we start shifting them up and down with a vertical shift, that horizontal asymptote also shifts up and down. All right, second part of this lesson is working with natural logs. Natural logs, if you go back to the calculator, That ln button stands for natural log. Now the reason it's ln instead of nl is that in the original language when they came up with this, it was like logarithmic natural or something like that. And they just never changed it. All right, so what natural log is log of base e. E is a really special number when it comes to exponentials and logarithms. And so it has its own special constant, and it also has its own special logarithm. And it comes up so often in calculus that it's just easier if you just keep it as ln rather than, it saves you a couple of digits to write. Natural log is the inverse of e to the x. That means it has its own inverse properties. Natural log of e to the x is equal to x. What we learned in 7.5 was that if we take a log of something and it's that same base raised to a power, that these things cancel out and it's just equal to x. Same idea here. Natural log and e just cancel out and it equals whatever that exponent is. Likewise, if we take e and raise it to natural log of x, they cancel out. If we do something like this, where we're taking a base, raising it to log that same base of x, those cancel out, and it's just equal to whatever this happens to be. Same thing here. E and natural log just cancel out, and it's just equal to x. So 3 quick examples of this. 2 of them are really super simple, and then 1 of them is just barely more complicated. So one like this, natural log of e to the negative 2t. Literally just cross those 2 things out, and it's negative 2t. Here, e to the natural log of t minus 1. Again, just cross them out, and it's t minus 1. Over here, it's just a little bit more complicated. Notice that the e and the natural log part are not right next to each other. I have to get this 5 out from in between the 2, and I can use one of the properties of logarithms that we learned about earlier, the plog one, the power property. I can take that number that's in front and I can move it to the exponent. When we learned about this, we did more moving it from the exponent out in front, but you can move them back and forth depending on what's convenient for that problem. And in this case, it's more convenient to move the 5 over to the exponent. That makes it e to the natural log of x to the 5th. Now that the e and the natural log are next to each other, cross them out, x to the 5th. Homework assignment that I'm going to check on Monday is here. This is actually how you find E. And this is more of something, a couple of years when you're taking calculus, you'll talk more about what this means. And in pre-calc, we'll talk a little bit about what this is, but we won't actually do the calculation for it. We'll just kind of show why it is. All right. And that's about it. If you have any questions on this stuff on Monday, feel free to ask a question, and we'll try to get this stuff solid for the test on this next week.